All right, so what is the question now? The first one.
Calculate the reactive capacitance.
Okay. The first question is the capacitive reactance, right?
Yes.
And then capacitive reactance is represented by the letter XC, right?
Yes, sir.
XC, is not?
Yes, sir.
Therefore, our XC is giving us 1 all over 2 pi FC. Am I right?
Yes, sir.
Good. So we are going to substitute without wasting time. So our XC 1 all over. So what do we have? 2 brackets close, bracket open, 3.142. That's the value of the pi, right?
Yes, sir.
And then we have a frequency is 50 hertz, right?
Yes, sir.
Good. Then the value of the capacitor is 5 microfarad. Am I communicating?
Yes, sir.
Good. So we have 5 times 10 minus 6. Okay?
Yes, sir.
All close. So evaluate what you have.
636.53.
Come again.
636.
636. 636. Point what?
54.
54. Reactance, capacitive reactance, remember, is measured in what? Ohms, right?
Yes, sir.
So we put our value, this. So that's the capacitive reactance of the capacitor, right?
Yes, sir.
So the second question is what? Second question, let's quickly attend the second question.
The current in the circuit.
Oh?
The total current in the circuit.
Current in the circuit. The total, we are going to calculate the current in the what? Circuit, right?
Yes.
The current is represented with letter I, right?
Yes, sir.
So for us to calculate the current in the circuit, we have the resistor giving us 500 ohms, right?
Yes, sir.
We now have the capacitive reactance giving us 606.3, right? Ohms. Are you with me? Yes. Yeah, so that's what we have.
6.
Okay, 636, okay?
Yes,
636, right?
sir. Yes, sir.
So we have 636 point what?
54.
54 ohms. That's the value of the reactance, right?
Yes, sir.
So the next thing we need to do is we find impedance. Once we find the impedance, we'll be able to find the total current flowing around the circuit, right?
Yes, sir.
So the impedance is going to be Z is equals to root square root of R squared, right?
Yes, sir.
Then minus XC squared. That's the capacitive reactance, right?
Okay.
So what we need to do is substitute accordingly. For R, we have 500 squared. For this, we have 636, right?
Yes, sir.
We can approximate to 7, right?
Yes, sir.
Squared. I'll quickly do that. Let's see what we have. So what do we have? 500 squared, right?
Yes, sir.
500
500 square is 250,000.
Okay. That's the first one. 500 squared is 250,000, right? Minus 637 squared. What do we have? 637 squared.
405,769.
Call it digitally. 405.
769.
769, right?
Yes, sir.
Good. So, subtract 250 there. Remember, we are having a squared, so this will turn to plus. Okay? Because this is affected by this, is going to turn to what? Plus. Quickly. So, what do we have? Are you still there with me?
Yes, sir.
So, what do we have?
655,769.
6 what?
55769.
So, this plus this, right?
Yes, sir.
Is going to give us 6, 5, 5,
769.
769. Is that?
Yes, sir.
All right. So let's quickly find the square root. What do we have as the square root? What do we have as the square root? The square root of 655,769. What do we have? Quickly. Just square root 655,769.
809.
Okay, 809, right?
Yes.
Any decimal?
Yes, 0.79.
0.79. Okay, so remember that impedance is also measured in what? Ohms. So we put our unit ohms. Therefore, what we have here is the value for the impedance. Let's quickly write it out somewhere here. The impedance have been found to be 809. Are you with me?
Yes, sir.
Okay, and then what? 0.79 ohms. So now we have found impedance, isn't it?
Yes, sir.
Good, we can now find the current, the total current flowing in the circuit. Are you with me?
Yes, sir.
So the total current can be found by using this formula I is equals to V all over the impedance, right?
Yes, sir.
You still remember from Ohm's law,
Yes, sir.
okay? So if we do that, it's very simple. What we need to do is to substitute volts, okay?
Yes, sir.
We have 10 volts,
Yes.
which is, we put 10, right?
Yes.
And then the impedance is what we have here, right?
Yes, sir.
Which is 8
Yes.
over 80 what? 9 point what? 779. Are you with me?
Yes, sir.
So what is the final value here?
0.012.
Hold on, 0.012 what? 2. Current is measured in what? Ampere, yeah?
Yes.
So we put A. Solved, okay?
Yes, sir.
That is it. So, any question at this point?
No.
I think it's clear, right?
Yes, sir.
Very good. So we are going to stop here and they will join us now in this lesson class.